spirit of Christmas, we will be talking about Christmas lights and some of the physics that goes behind it. For lights in series, electricity passes from the power source to one bulb and then to the other bulb, while lights in parallel each have its own circuit to the voltage source. Today we'll be comparing Christmas lights in series versus parallel, and to see which is more desirable for production.
Okay, so in terms of voltage, when we want to talk about Christmas lights, we know that these Christmas lights are going to be in parallel. This is a typical Christmas light setup. So ultimately what that means is that the voltage for this one is going to be equal to this one, which is equal to this one, and this one, and this one. Now how do we know this is through the equation. So voltage is equal to IR. So ultimately a really easy way of looking at this is that 10 positive particles are coming from the voltage source. This is typically going to be a circuit in the wall, or plugged in the wall. So what's going to happen is 10 particles are going to come out. So you have one current here, I1, which is ultimately equal to the 10 particles. This is going to split into two currents. This is going to be I2, and this one is going to be I3. I3 is going to have 2, let's say, that's just a number, and then, yeah. So then I2 is then going to split into I3, I4, and I5. Now we know that because each bulb has the same resistance, this I4 has to be the same as this one. So ultimately the resistors are the doors allowing the positive particles to come through. Because they're the same resistance, they have to have the same number of particles coming through. So I5 is going to be split into I6, I7, I6 is again 2, I7 is going to be split into I8, I9. And then I9 is going to continue down. We know that this is 2 still. So I9 is going to come down because we know that this ending number is 2, so it's going to come down. And then here everything's going to sum back up until this is back to I1. So ultimately, now that we know that the resistance of each bulb is the same, and the current of each bulb is the same because the same amount of particles is going through, then ultimately the voltage of each is going to have to be the same.
Because all of these individual currents have to add up to the total current that we had in the beginning of 10 positive charges, that means each individual resistor or bulb has to have the same amount of current going through it. And because they all have the same resistance, that means, and the same current, that means they have to all have the same power. Now, if we were to take out one of the bulbs, or one was to go out, then the current in each of the other bulbs in this one would have to be 2.5, because to make up for the one that was missing, and it would still have to add up to the 10 positive charges that we had in the beginning. And ideally they would all slightly increase in power, but in real life you wouldn't really notice because of how many bulbs there are usually in one. Also, because we know the power is the same, that would mean the brightness for every single bulb would be the same. So in a string of lights, all of the brightness of each bulb is the same.
Okay, so right here we have a circuit in series. And so we know from circuits in series that there's going to have the same current through each bulb. So that means that, say I cut this one out, then all the light is going to go out in the other ones because they share the same current. That's why parallel is much more preferable, because if you cut one, the rest of these will they share the same voltage, so the power will still be the same.
For lights connected in series, as a backup plan when your filament burns out, a shunt wire is often used, which keeps the circuit closed and allows electricity to flow through even though one filament may be broken. In conclusion, Christmas lights in parallel are ideal. However, it is easier to produce lights in series. A common practice now is to produce a string of lights in series parallel, wherein a set of lights in series are connected in parallel to another set of lights in series. This may be why if one bulb goes out in your string of lights, a whole portion or a portion of your string may go out, because that is the portion of the lights in series.